Hello everyone, I'm going to be going over how to work with different types of fluid physics simulations in Blender. I've done a little bit of organizing in my scene here, so I have a new collection for my fluid simulations. I've moved the cube over into it. I'm just going to take a moment to rename the cube. It's going to act as what we call the domain, which is sort of the boundary of the simulation. Now, the domain can be any type of object, but it's always going to act like it's a cube, so it might as well be a cube. I'm just going to press S to scale that, so I have a larger space to work with for my boundaries. Now, notice that the scale is up to 3.5. I need it back to 1 so that this scale is recognized as the default. Control A to apply the scale. Now my scale is back to 1, so the actual scale will be recognized. If I make a change to the size in object mode and don't apply that change, it's going to really throw off how the simulation behaves. So that's an important step. All right, I'm going to come over to the physics settings, which is this one right here. I'm going to turn on fluid, and the type is going to be set to domain. Now, when I first set the type to domain, I can choose whether this is for gas, so fire, fire and smoke, or is this for liquid. I'm going to switch into wireframe temporarily as I'm working, and I'm going to add Shift A in the mesh menu, some sort of object to act as my source. So I'm going to add a UV sphere, maybe move it up towards the top. There we go. I'm going to turn on fluid physics. This time the type is going to be the flow object. It's going to be a source. And I need to change the type to liquid. If I play my simulation from the very beginning, you can see how the fluid is behaving just with the default settings. And you can see that the domain is acting as the boundary. And actually, if I take a look now in solid shading, you can see that there's no longer the cube because the cube actually is the mesh of the fluid itself. So that's something that's important to be aware of. All right, now there are a lot of settings that can change the behavior and how things are going to work. So right now, it's acting as geometry, the sphere, and actually I'm just going to rename that to source just so that it's really clear. I could set this to inflow, and then when I play through from the beginning, you can see that it's continuously pouring in. Now, something else that you can do is actually animate this. So is flow active or is it not? Maybe at the start it is active and I might add a keyframe, but maybe by frame 30 it's going to turn off, so I might uncheck use flow and add a keyframe. So now when I play through from the beginning, it pours in, but then it turns off so that I have a limited amount of fluid there. All right, now if I want to, I can change whether this is starting from the beginning or not. So I might uncheck use flow and then add a keyframe, and then maybe on frame 20 it's going to turn on. So I'll check use flow, add a keyframe, and then maybe I'll just right click and drag my other keyframe to end later on. So now when I play through, it delays when the fluid is added, and then it stops. Now you'll notice that the domain appears while flow is turned off instead of looking like fluid. So what I would want to do is keyframe the domain so that it's not actually visible. So on frame 1 where the domain shouldn't be visible, I can just turn off visibility, press I to add a keyframe. Frame 20 where that's going to change, I can turn visibility back on, and I to add a keyframe. So visually, while I'm working, I'm not going to see a change, but when I'm actually rendering later on, it's not going to show the domain until it actually needs to show the domain. So that's something that's helpful. Now, there are a lot of other settings that you can experiment and even animate. So we can have initial velocity, so to control the direction the fluid is added on the X, Y, or Z axis, or even all three. We can, if we go to the domain, just so many different settings that we can experiment with depending on how you want the fluid to behave. And if you do a little research, people have some formulas for different settings that you can enable that will make the fluid behave more like different types of fluids. So water versus honey versus oil and that sort of thing. But at its most basic, the most important thing is actually the resolution divisions here. So keep it at a low number when you're figuring things out and just experimenting. But when you need to actually test this out with a better quality, you can increase the number. And I'm just going to switch back to wireframes. It's a little bit faster. And always go back to the start before previewing any change. Again, the fluid is turned off for the first 20 frames, so we're not going to see anything. You might notice that this is particularly slow right now. That is expected because the resolution is more than doubled, but the quality of the fluid movement is going to be significantly increased. So when you have the general behavior right and you just want it to look more realistic, then you'll increase the resolution divisions, though I do highly recommend waiting until the rest of your behaviors are pretty much what you want. So we can already see that the quality is significantly better than it was before. It's starting to look more realistic. I'm just going to pause this here and do a couple of other changes. So I'm just going to go back to the very start. I'm going to add a cylinder and just slide that down, and then over in edit mode, I'm going to just delete. If I can select it, I'm going to delete that face up top. And I'm just going to make this into a little bit of a cup. So I'm going to scale that out and maybe move this up a little bit more. Now, because I'm moving in edit mode, it doesn't impact the overall scale, so I don't need to make any changes. Now, by itself, this isn't going to work quite as well as I want it to, but I just want you to see the default behavior. I'm going to lower the resolution back to 32, so this will be a little bit faster to see the general behavior. I'm going to grab my cup, turn on fluid physics, and this time the type is going to be effector. So if I start from the beginning and play through, the water is going straight through. Now, there are 3 or 4 things that have a really big impact on how effective effector objects are. Now, first of all, this doesn't have any thickness, and it needs thickness to work well. So I'm just going to go over, add the solidify modifier to really quickly add some thickness. I can decide how thick it wants to be, maybe something like that. And actually, before I apply the modifier, I think I also want to add some more subdivision, so I'm just going to add a loop cut with a number of cuts just so that the mesh itself is a little more detailed. Both having more subdivision in the mesh and having some thickness in the mesh should have it respond better. So now I can apply the solidify modifier, and I'm going to go back to the domain. And sometimes the physics doesn't update automatically when we're working with fluids, so increasing or decreasing the resolution can make it more likely to behave better. Now, that is still going through my effector object more than I want it to be. So next thing to try is experimenting with the surface thickness. I'm going to just put this up to 0.5 as a starting point. I might spend a little more time experimenting, but now I'm going to play through. And you can see that while there was a little bit of leaking at the bottom, that's significantly better than before. All right, I'm going to select my domain. Or actually not my domain, I think I want my source. And I'm just going to move this keyframe so that the water isn't on as long. So that amount is definitely better. I could even make that shorter, but I think I'll live with that as it is. But there's definitely still a little bit of leaking coming out the side over here. So there are, at this stage, two things that I can work on to improve the behavior. One is just in the effector object itself, experimenting with the settings that I have here for the sampling subsets, the surface thickness, so continuing to mess with those settings. The other thing that's going to have a big impact is actually the domain resolution. When you have a low resolution, it's more likely to be leaking. As you increase the resolution, you should see improvement in that area. I'm not going to play it through at this stage because it's just going to be really, really slow calculating, but that is the general process. Now, you may have noticed once we get the resolution up there, it's really slow processing and we just want it to be faster. So we can actually what we call bake these simulations so that it doesn't have to keep calculating every single time. Now to do that, we have this cache area. I want to make sure I choose my own cache location. So I'm just going to go somewhere easy to find. I'm going to make a new folder. And after I've created the folder, I'm just going to enter it and accept it. And now I have my own custom location. I can decide how long I want the animation to be at this stage. So maybe this is only going to go, actually let's go up to 90. And I want to change the type from replay to all and then bake all. Now, depending on the resolution and how complicated your scene is in general, sometimes baking is really fast if you keep the resolution really low, and sometimes it is really, really slow. All right, I sped that up just so that you wouldn't have to wait as long as I did to see the simulation. So now that that's baked, I can play through. We can see how everything is looking. Much more dramatic water. Maybe still a little bit too much for the cup itself. And at that point, it's no longer baked. All right. Now, you may notice that a lot of settings get disabled after you've baked. So if you realize you need to go back and make changes, you just click on Free All, set the type back to replay, make your changes, and then come back in and bake when you're ready. And again, make sure you have your custom cache location so that it's easier if you end up backing up your file or moving to another computer to render. Now, the last thing I want to mention about actual fluid simulations is that the material is based, I probably should have switched to cycles for the engine. The material for the fluid, I'm just going to go to a frame where we see the fluid, is based on the domain object. So the domain actually becomes the fluid. I like to use maybe a mix shader, sometimes combining glass that's just a little tinted towards blue with maybe a translucent or a transparent shader. Again, a little bit towards blue. Then we can see what the fluid ends up looking like. Now, depending on what you have going on, you may or may not want your source object to be visible. Again, you can just hide that in the simulation itself by turning off the render icon, and that will keep it hidden all the time. Or you can keyframe it like we did for the domain earlier. And we can just hide it all together to see what that ends up looking like. Again, the cube part of the domain won't be visible because that's been keyframed to be hidden. All right, so that is the basics of working with fluid, and hopefully that'll be enough to get you started. Now, I'm actually going to remove all of my objects and I'm going to start this simulation over. Just want the right collection active. And I'm going to add a new domain. Go back to probably solid. And I'm just going to scale that up. Control A to apply the scale. Back over to physics, fluid. This is going to be my domain. And so we have two types of fluid simulations. We have the gas simulations and we have the liquid simulations. So this time I'm going to leave the types of gas. Shift A for the add menu. And again, I'm going to use the UV sphere as a source, but it really could be anything. And I'm going to turn on fluid. The type is going to be flow. And just as is, we can see how that's behaving. So right now, the type is smoke, the behavior is geometry, so there's a limited amount. I'm just going to lower this down, change that to inflow. Now it's going to continuously come in. If I want to sort of drain the smoke, and actually this works for all of the different fluid simulation types, I can add an object that's going to act as an outflow object, sort of like an exhaust fan. Again, anytime I make a change in scale when I'm in object mode, I just won't apply with Control A. I'm going to turn on fluid physics. Will be another flow object, but instead the behavior is going to be outflow. So when I go back to the start and play through, it's going to start removing smoke from the scene so it doesn't build up to the same extent. I can turn off the visibility in the render if that's not something that I actually want to see, but otherwise I can just leave that as is. Just adding Suzanne and fluid. Just like working with the actual liquid, we can have effector objects. And you can see that the smoke gets pushed away a little bit by Suzanne because Suzanne is an effector. Depending on the behaviors you're getting, you might want to experiment with the other collision settings over here, but I'm just going to leave the defaults for now. If I want to animate this, having the smoke turn on and off at various points, maybe on frame 0, or sorry, maybe on frame 1, I'm going to put the density all the way to 0 and keyframe that. And maybe up to frame 20, it's still going to be 0, so I might add another keyframe there. And then maybe between frame 20 and frame 40, it's going to transition to have full density, so I can change the density, keyframe that. So now when I play through, there's a delay before the simulation starts. And if I get to a point where it's going to stop smoking, maybe let's say frame 70, I can put the density back to 0, add a keyframe. Now it's going to gradually, after it becomes enable, gradually turn off between 40 and 70. So if I want it to start turning off a little bit later, I can always add another keyframe. You'll notice that the domain has a huge number of settings. Again, that will control how the smoke is behaving. So that's definitely something you can experiment with. Just like the other fluid physics, we can set a cache location. I'm not going to bake this now, but it's the exact same process. Choose your own folder location, choose the start and end frame, set this to all, set to bake, and whenever you're just testing playback, leave it on replay. All right, now I'm going to take a look at this in the rendered view. Maybe on this frame because the smoke is really clear. And notice there is no visible smoke. We have to do something very specific with the materials for this to work properly. So I'm going to come over to shading, and I'm just going to do, and actually we want the domain selected. The domain is the material, well, it's the one that needs the material for the smoke. So plus new to create a material. I'm actually going to remove the default shader, so just X to delete, normal shortcuts apply. I'm going to keep the material output. Now this is going to be a little bit complex. I'm going to use Shift A for the add menu. I'm going to search for an add shader. And this is going to be connected to volume instead of to surface, so it looks a little bit different. Now I'm going to add, I want volume scatter, and this is going to be connected to the top shader. And I also want volume absorption, and this is going to be connected to the bottom shader. I'm going to add my first attribute, and the name of the attribute needs to be color. And I'm just going to drag from the color socket to the color socket on both volume scatter and on volume absorption. And then next, I'm going to search for a math node and connect that to the density for both volume scatter and absorption, but I want to change the mode from add to multiply. And I'm going to add one last attribute. So I used it recently, it's right there. And the factor is going to override the first value. The name for this is going to be density. I'm going to increase the other multiply value up to 5 just as a starting point. That looks good. So when I switch to the rendered view, now we can actually see the material. And I can play around with my density value here to have a big impact on how thick the smoke ends up looking. Now, one last thing I want to mention about the fire or the smoke part of the simulation is that just like with fluid, the resolution has a huge impact on the quality. I'm just going to go back to wireframe temporarily, or solid, doesn't really matter which one. If I increase the resolution, the higher it gets, the more believable the smoke is going to start to look. I didn't raise it up that much, but you can already see that it's starting to get more detailed. And that will also have an impact as we're looking at it in the rendered view over here. All right, I'm going to go back to solid, and I'm going to switch the source from a smoke object or a smoke type to fire and smoke. Or actually, no, I'll go back to fire and smoke. I'm going to change it to fire. So using the other settings, notice there's not a density setting like there was before. So I'm just going to let that play through. Again, the higher the domain's resolution, the more realistic this is going to look. If I want to keyframe when the fire starts, I need to keyframe the fuel setting. So setting that to 0 when I don't want any flame, adding a keyframe. Wherever I want the flame to start, turning fuel up however much I want, adding a keyframe. And when I go through, I should have a delay for the simulation starting. Now, if I want a little bit more, if I want the transition to start later, I can add another keyframe. So maybe it's still going to be 0 at this point. So completely off for a little while, and then turn on and do whatever it's going to do. Now, if I take a look at the rendered view, we're still only seeing smoke. So fire actually needs a different type of material. So I'm going to head back over to shading. I'm going to go back to my domain, and I'm just going to name the original material smoke, and I'm going to X out that material and make a new one. So just like before, I'm deleting the shader, just leaving the material output. This time I'm going to add an emission shader, so always Shift A for the add menu. This is still connecting from emission to volume instead of to surface. I'm just going to switch over to the render view, and I'm going to search for color ramp, which we've used previously to add a gradient. The color is going to override the color. For now, I'll leave it at black and white, but I can change it to whatever I want later on. I'm going to add another math node because I've used it recently. It's right here. And that's going to connect to strength. The operation type is going to be multiply instead of add. And I'm going to add one attribute. And so this one is going to connect from vector to the color ramp's factor, and it's going to connect from factor to the top of multiply, and the name for this is going to be flame. And notice none of this works until that is correct here. Now, depending on how I want the fire to look, I might significantly increase or decrease the multiply value. And again, I can play around with the exact color that I want the fire to be depending on just what I like the look of. Maybe it's going to be sort of like some sort of magical fire. I can add additional color stops, and they will have an impact on the colors as well, and just where the color stops are located are all going to have an impact. So you can get some really interesting visuals with the different colors that you choose and how close you put those color stops together. So you can make more of a mystical fire, you can make more of a natural fire, depending on the colors and locations and how many color stops you end up adding. And even just the overall value of the different color stops is going to have an impact. So lots of things have an impact there. All depends on how dramatic you want it to look. All right, so that is how you set up your material when you're working with fire. Right, so back over to layout. I'm going to go back to solid shading for a little bit. The last flow type we have is fire and smoke, which is combining these two things together. Now, it's recognizing the keyframes that I previously set, both for density and fuel. So again, that really controls when the different aspects are going to be enabled. But you can see now I have both fire and smoke at the same time. Now if I go back to the rendered view, you'll notice that the smoke doesn't really have a material the way that the fire does. So we need to put the two materials into one material. So I'm going to go back to the domain. Now I'm going to switch this back to my smoke material and use this as a starting point and just sort of combine these together. I'm just going to put this off to the side. And so this is literally fusing the two materials together. I'm just going to do Shift A. I'm going to search for an add shader. If I hover over the connector, it'll automatically get connected. So my smoke is connected to my upper slot. And then I'm just going to repeat what I did previously for the fire material. So I'm going to look for my emission shader. That's going to get connected to the second slot. I'm going to search for color ramp, color connects to color, and I can set whatever I want the colors to be. And again, I can have multiple colors, just whatever I want. All right, so that looks good. I need another math node that is going to connect to from value to strength. The operation type is going to be multiply. And then last up, I just need another attribute, which is connecting from the vector to the factor of the color ramp and from the factor of the attribute to the first value for multiply, and the name needs to be flame. I do want to mention for all of the attributes, you really need to make sure they're written exactly the same and no uppercase. Everything is lowercase. I can continue to adjust the different settings of the various materials depending on what I want this to look like. You can do a lot of customization as far as the material goes. All right, and just a couple last reminders. When you are working with this type of simulation, the material goes on the domain. The resolution divisions has the biggest impact on the quality that you're looking at, so always make sure to increase that before you actually render. But it'll also really slow down the rendering process, so do the highest amount that you need, but no higher. And then to speed things up, don't forget to bake the simulation to your own cache location with the type set to all. And that's pretty much it about the basics of working with fluid and fire.